Hi everyone, welcome back to all of you on my YouTube channel. I'm Ankit Mishra. I'm teaching for the GATE Chemical Engineering for last 5 years. So here I'm coming with revision series of chemical technology. So in previous lecture already I've discussed about the petrochemical industry. Here I'll be talking about the sulfuric industry that is very important for GATE Chemical Engineering 2025. So if you talk about production of sulfuric acid, so generally three major industrial processes are available for production of sulfuric acid. So we have H2SO production. So we are going to study about the H2SO production. So we have three industrial method that is there for sulfuric acid production. So first is your contact process. Second is your lead chamber process. And third one is your DCDA process, that is called as the double contact double absorption process. So this is just a modified version of contact process only. So the contact process and DCDA process is very much similar, but here only you will see the difference is 2 times absorption and 2 times contact is happening, right? So first I'll start with the contact process. So since this is a revision series, so I won't be stretching the lecture. I'll try to complete in very small interval of time. So this is very dominant method for production of H2SO4 and having efficiency. Here production efficiency is very high. So efficiency and purity, if I am talking about by contact process, that will be very high, right? And how these things is happening. So first I'll be talking about the steps required here, right? So first step, in first step what you will see that sulfur is going to react with oxygen. Oxidation of sulfur is taking place and it is going to form SO2. Is that clear? So sulfur will be raw material and it may be the pyrite soil or where sulfur is there. And then what will happen? And since oxidation is happening, so obviously this reaction will be exothermic, right? And then what happens? 4Fe(S2) is going to react with O2. This is pyrite ore. So from here only these things can be extracted and it will give you 2Fe2O3 plus 8SO2. So ultimately you are producing the sulfur dioxide, right? That's it. So either you are using pyrite ore or you can directly use the sulfur. Second step required here, that SO2 is passed through a vanadium pentoxide catalyst. So next step you will see SO2 is passed through a vanadium pentoxide V2O5 catalyst at 450 to 500 degrees centigrade and 1 to 2 atmospheric pressure to form SO3. So here you will see 2SO2 plus, again oxidation will take place and the catalyst here that will be used is V2O5, that is very important, and it will form 2SO3, right? And this one is the slowest step that will determine the rate of production of H2SO4. Okay, so once this step will form, again this step oxidation is happening, so this is also an exothermic reaction. And since exothermic reaction is there, then better control required in this particular things to maximize the efficiency. Now coming to the third point, here then it will be absorption of SO3 into H2SO4 to form oleum. So why these things is important? Because SO3 is not absorbed in water, right? So if you will see, SO3 is not absorbed in water. So these kind of questions can be asked in your GATE, because a superficial question they are not asking this time. So why absorption step is required during the production of SO3? Because SO3 is not H2SO4, because SO3 is not absorbed in water, right? And it forms a hazardous kind of chemicals, right? But absorbed in concentrated H2SO4. So SO3 is absorbed in concentrated H2SO4, and when it will absorb in concentrated H2SO4, you will see the reaction will be happening. SO3 plus H2SO4, it will form H2S2O7. This is called as the oleum, right? And since SO3 is very much absorbable, I mean it is going to absorb in H2SO4, not in water. That's why it will react with H2SO4 to form oleum, right? And after that, in the fourth step, what you will see, that dilution of oleum to form sulfuric acid. Dilution of oleum to form H2SO4, right? So here you will see that oleum H2S2O7, it will react with water, means it is getting diluted with water, and it will form two molecules of H2SO4. So what we have seen here, first in this particular steps, what had happened, that sulfur is going to react with oxygen to form SO2. This reaction is your exothermic reaction. Then the second step, SO2 is reacting with O2, and again it is forming SO3. You can balance the reaction, right? And the catalyst here used is V2O5. In the next step, SO3 is not absorbed in water, so it will react with H2SO4, and it is going to form H2S2O7, which is your oleum, right? So this is exothermic reaction, this is your exothermic reaction. And then it comes to the dilution step, where H2S2O7 react with water molecule, it is getting diluted, and it is going to form two molecules of H2SO4. So this is the overall picture of the contact process, where two reaction is happening, two oxidation reaction is happening, and both of these reaction is exothermic, and catalyst used is vanadium pentaoxide. And then since SO3 is not absorbable in water, so you have to absorb in H2SO4, and once it get absorbed in H2SO4, it will form oleum H2S2O7. And now H2S2O7, ultimate thing is to produce H2SO4, so you can use dilution method to calculate, to prepare the H2SO4, right? Now, so in this particular process, you will see the purity of H2SO4 will be tending to 98 to 99%, which is a very decent purity. And this is very economical and efficient process, and less pollution compared to another method, right? And now, why we are using vanadium pentoxide? Advantage of V2O5 vanadium pentoxide using in this particular process, that it is immune to poison. So catalyst should not get poison, otherwise it will efficiency of catalyst will get reduced, and this requires in very less amount. So out of 10 kg of 10 kg of this V2O5 is required to produce 1 ton of sulfuric acid. So you can see the quantity of vanadium pentoxide required is very less, and due to this particular region, you can see that low capital cost. And the fourth one is it can be easily regenerated. So you can say only 3% is to be replaced per year, which is very decent quantity. So these are the advantages of using vanadium pentoxide, and it is very much advantages of producing H2SO4, that is immune to poison, requires very less amount. That's why this decreases the capital cost, and regeneration, it is very easily regenerated, right? Now, when we talk about the flow diagram, that is very, very important. Sometimes the questions can be asked from flow diagram. So what kind of equipment that can be used in production of contact process, using for production of H2SO4 in contact process? So first you will use burner. Why? Because obviously oxidation reaction is happening. Then you need catalytic converter. And again, then you need oleum absorption tower because H2SO4 is not very much soluble in water, sorry, absorbable in water, so you require oleum. That's why oleum absorption tower. And after that you can say that 98% that H2SO4 absorption tower, where oleum is being absorbed or getting diluted with water to form the H2SO4. So this step is very very important: burner, catalytic converter, oleum absorption tower, and 98% H2SO4 absorption tower. And this first you will be using this equipment, then second, this one is third step, and this one is fourth step. So this one is the reaction, equipment, the series of equipment that is being used, and this one is the series of reaction that is being used. First this reaction will happen, second this reaction, third this particular step will happen, and fourth one is the this process, right? Okay. So earlier what was happened, PT was used as a catalyst in contact process, and later on V2O5 came. So I have already discussed the advantage of V2O5, but what was the disadvantage of platinum? So because it required larger amount of this, larger quantity is required, which increases the capital cost. And if you will see the feed to catalyst ratio, 7 to 10% of SO2, so that much variations was there. That's why the most major disadvantage of using platinum as a catalyst was it required in very large quantity, that is undesirable for the production, and ultimately it was increasing the cost of production. Okay, now coming to the late chamber process, that is the second process. So only I am teaching that can be asked in the GATE exam, that's it. So the lead chamber process was historically used, but now largely absolutely due to lower efficiency. So the efficiency and concentration product efficiency is very less. So here you will see the efficiency or concentration of H2SO4 that is being produced is only 62% concentrated. So the concentration is very less. So again you have to concentrate these things after the process, after post processing, right? So what is steps here, what kind of steps are required here? You can see that first again that you will be producing production of SO2, right? So sulfur or S plus O2, it is getting converted into SO2, or any pyrite or it is getting oxidized and it will be producing SO2. So again oxidation is there, so exothermic reaction will be there. Second step, it will require SO2 will react with half O2 and it will be producing SO3 also, right? So sorry, so again this steps require, second steps require production of SO3 from SO2, right? How is it happening? So this step is happening in place of SO2, it will react with nitrous oxide plus water, it will be producing H2SO4 plus NO, right? So here you can see the catalyst that is being used in this particular step is nitrous oxide or nitrogen dioxide, right? So these kind of catalyst is used in lead chamber process. Earlier V2O5 or platinum was used. Nitrogen is regenerated and reused in the reaction. That's why you can save some amount of money, because here you can see that nitrogen is regenerated during this particular reaction. And then it comes to the absorption of SO3, absorption of SO3 in water, right? So SO3 dissolves in water, forming low concentration, because obviously in the earlier stage I have told you that SO3 is not very much absorbed in water, right? So here you can see that if you want to dissolve SO3 in water, then concentration of H2SO4 being produced is very less. So you can write here that SO3 dissolves in water, forming low concentrated sulfuric acid, which is only 62%. So what is major disadvantage of late chamber process. So the major disadvantage here, you can see that purity is very less. Second one is less efficient, and third one is large space is required. Large space is required. That is not very much important, very much desirable for any plant, right? That is the major disadvantage. But here the most important thing that I can tell you, that what kind of catalyst is being used for the production of H2SO4 in late chamber process, and that catalyst is your N2 or NO2 or NO. This is very important catalyst, N2 or NO, something like that. These questions can be asked. Now coming to the double contact double absorption process. So this is not uh, this is very similar to contact process, but only that is modified version of contact process. So third one is your DCDA process. So in contact process, what we have seen, that sulfur was getting oxidized to form SO2, and then again SO2 was getting oxidized in presence of V2O5 to form SO3, and then SO3 was getting absorbed in H2SO4, and it was forming oleum, and again oleum was getting diluted with water to form SO3, right? But here what is happening, two more steps are required, and it is going to produce 99.8% of the purity of the H2SO4. So the purity in double contact double absorption process was increased. So here I can say purity is equals to 99.8%, which is very high. This is tending to approximately 100%. That is very much important. Earlier it was 98 to 99% only. So it involves two catalytic oxidation process and two absorption process. And higher SO2 conversion efficiency 99.8%, right? And lesser environmental pollutant. So first step I'll be talking here is SO2 production. So I'll be writing the steps only. Then SO2 to SO3 production, and again then first absorption of SO3. And once first absorption will happen, so here you can see that 98% H2SO4 forming oleum. So here oleum will get formed, and then unconverted SO2 is recycled and again oxidized. So here unconverted SO2 will be there, and it will get recycled. Unconverted SO2 will be there, and it will get recycled. So unconverted SO2, it will come in this step, and again it will form SO3, and once it will get oxidized again, so that it will improve for improving SO3 efficiency, right? And then again second absorption process will start. Second absorption process. So here you can see that double contact is happening and double absorption process is happening, right? So again second absorption process will happen. So here you can see that SO2 is coming in contact 2 times, and again 2 times absorption is happening. That's why finally you will be getting 99.8% of purity of H2SO4. So that's why this is called as double contact double absorption process, where unrecycled or unreacted SO2 is again recycled back to produce SO3. That will increase the conversion efficiency of SO3, and then second absorption process is being done, right? So the major disadvantages of DCDA process is it maximize the SO2 conversion and lesser air pollutant, because ultimately again you are recycling all of these things. So SO2 emission is very less in atmosphere, because you are again maximizing the SO3 conversion and produce high purity of H2SO4, and this is more efficient than late chamber process and contact process, because purity is very high. Okay, so this is all concept that is related to the contact this H2SO4 production, that is contact process, late chamber process, and DCDA process, where you have seen that DCDA process is very much important. And DCDA process produces a higher purity of H2SO4 compared to the another. Is that clear? Okay, so here with that I would like to end this lecture, and in the next lecture I will be starting with the chlor alkali industry. Okay, thank you.